the reaction of toluene with chlorine in the presence of ferric chloride gives predominantly which of these products? So, let us write this reaction here. Reaction of toluene, benzene attached to CH3 is called as toluene. So, we have toluene, and in this case it is reacting with chlorine in presence of FeCl3. This FeCl3 is a Lewis acid. Its job, FeCl3's job, is to react with chlorine and we get FeCl4 minus and we generate a Cl plus. Cl plus is electron deficient and hence we can call it as an electrophile. This is similar to AlCl3, catalyst AlCl3. AlCl3 also gives the same thing, anhydrous AlCl3. So, let us go back to this reaction. So, in this reaction, as Cl plus is generated, it will attack this electron rich benzene ring. Now, as methyl group, CH3 group is an orthopara director, it sends this incoming Cl plus to either ortho position or para position. This is also ortho position. So, either here or here, that would be the same compound. The other compound obtained is when the attack takes place here. So, let us write the products. So, CH3 will remain here only. You get Cl plus attacking at ortho position and Cl plus attacking at para position. The name of these compound would be orthochlorotoluene and parachlorotoluene. The byproduct here would be HCl. There is an H here, H plus, which goes with the Cl minus, regenerating the catalyst FeCl3. Now, why this reaction is very important for competitive? That is because the same chlorination on toluene can take place in one more way, and this gives rise to completely different product. That is, now instead of catalyst, we will be using either heat or light. You can also see UV written over the arrow. So, in any of these conditions, heat or light, the reaction takes place at benzylic position or allylic position. We have studied that heat, electricity, light gives rise to free radicals by homolytic fission. Now, Cl plus is not generated. Instead, Cl free radical is generated. So, attack does not take place on benzene, it takes place on benzylic carbon, that is here. This is also substitution reaction. One of this hydrogen is replaced by Cl. So, we will write the product. We have benzene and now we have CH2 and instead of H, we got a Cl here. This group here is called as benzyl group and hence this compound is called as benzyl chloride. This reaction can proceed further where we substitute one more hydrogen by chlorine, then one more hydrogen by chlorine till we get benzo trichloride. All the hydrogens are substituted by chlorine. So, these are our two options, that is either in presence of catalyst, attack takes place on benzene, and this substitution is electrophilic aromatic substitution giving orthochlorotoluene and parachlorotoluene. In absence of catalyst but presence of either heat or light or UV light, or maybe you can see high temperature written over the arrow in competitive exam. In that case, free radical substitution takes place at benzylic carbon and you can get either benzyl chloride or complete substitution to get benzo trichloride. Going back to this question here, so reaction of toluene with chlorine in presence of catalyst is there. So therefore, reaction takes place on benzene. What is our product? Ortho and parachlorotoluene.